Ever wonder what's actually making the magic happen inside your smartphone? You've got a literal supercomputer in your hand, but how is that even possible? Well, today we're going to pull back the curtain on the tiny, unsung hero of all our modern gadgets, the system on a chip. This is the miniature engine that has absolutely revolutionized our world. To really get how big of a deal this is, you got to look back in time, and not even that long ago, really. Computers were these gargantuan beasts. I mean, we're talking machines that filled entire rooms, guzzled insane amounts of power, and probably heated the whole building. The idea of carrying one in your pocket? Pure science fiction. So that brings us to the big question, right? How in the world did we manage to shrink all of that incredible power down to something that just slides into your pocket? That journey from a room-sized machine to a pocket-sized one is one of the coolest stories in modern engineering. And the answer, the key to the whole puzzle, is a truly brilliant piece of design, the system on a chip, or SoC for short. This is the all-in-one innovation that totally changed the game, and it's the star of our show today. So what is an SoC exactly? Well, think of it like this. It's a microchip that takes all the crucial parts of a computer, the brains, the graphics, the memory, you name it, and crams them all together onto one single slice of silicon. The magic word here is integrated. It's not just about making things smaller, it's about making them work together on one team. And when I say all the core components, I mean all of them. On this one tiny chip, you've got the CPU, which is basically the main boss running the whole show. You've got the GPU, which handles all the visuals and makes your games look pretty. You've got RAM for quick access memory, all the little doorways for things like your screen and camera, the power systems to keep your battery from dying in an hour, and even the radios for Wi-Fi and 5G. It really is an entire system on one chip. Now, jamming all that stuff together sounds incredibly complicated, I know, but there's a really great way to picture how it all works in harmony. I want you to stop thinking of it as a bunch of circuits and instead imagine it's a tiny bustling city. This analogy is perfect. It really hits the nail on the head. Every single part of the SoC has its own specific job, just like different districts in a city, and they all have to communicate and work together perfectly for the city and your device to run smoothly. And check this out, we can actually map this city idea onto a real diagram. The ARM processor, that's your city hall, the central command making all the big decisions. The memory controller is like the city's main library, managing who gets what information and when. The I/O stuff, like USB ports, are the city's harbors, letting goods and information flow in and out. And how do they all connect? Through a network of super fast highways called buses. It's this incredible organization that makes it all click. Okay, so that's the theory, but what does this look like in the real world? Well, maybe the best case study for the raw power of SoC design is a little company you might have heard of called Apple. Their whole approach gives them a massive, massive advantage. You can really see the two different philosophies in the market. On one side, you have Apple. They control the whole shebang. They design their own custom chips, the A series, and their operating system iOS, at the same time making sure they're a perfect match. Then you have the Android world. It's more of a mix-and-match situation. A company like Samsung or Google will grab a processor from, say, Qualcomm, and then tweak Google's Android software to run on it. That software has to be flexible enough to work on thousands of different hardware combinations. So how does Apple stay on top of the performance charts so consistently? Well, it boils down to three key things. First, they design their CPU cores from scratch instead of just using the standard ARM designs. This gives them way more control over performance. Second, since Apple is its own biggest customer, they can justify making their chips physically bigger and more expensive, packing in more power. And third, they have enough cash to basically buy up all the production capacity for the world's newest, most advanced chip-making tech, giving them a head start on everyone else every single year. And this quote just perfectly sums up the result. When the hardware and the software are built hand in hand, what you get isn't just a better score on a speed test. It's a faster, smoother, and just plain more reliable experience for the person actually using the phone. And that's what this deep integration is all about. All right, let's zoom back out from Apple for a second and just talk about the huge impact of this technology overall. Why was the system on a chip such a revolutionary idea for pretty much all modern electronics? Let's start with a number that is just mind-blowing. By putting power management right there on the chip, SoCs can be incredibly efficient. So efficient, in fact, that some advanced techniques can cut down on static power leakage, that's the energy your phone sips just sitting on a table doing nothing, by an unbelievable 97.6%.
Think about what that does for your battery life.
So if you boil it all down, SoCs give us 3 huge wins. Number 1, that incredible power saving, which gets the most performance out of every drop of battery juice. Number 2, space saving, which is what lets us have these powerful, thin, and light devices. And number 3, cost reduction. Turns out, putting everything on one chip is a whole lot cheaper and easier than trying to wire together a bunch of separate parts.
And because of those 3 big wins, the SoC has become the invisible engine driving almost everything in our modern lives. Yeah, of course, smartphones and tablets, but also all those billions of Internet of Things devices, the smart speakers in our kitchens, the crazy complex computer systems in our cars, and yep, the watches on our wrists.
But this technology is not standing still. Not even close. These chips are getting more powerful, more efficient, and more integrated every single year. Which kind of leaves us with one final, really fun question to chew on. What's next? What new device, or maybe even what entire industry, is about to be completely transformed by the next generation of the system on a chip?